Hi viewers, good to have you here. This is E Plus Academic Resource Center, all right? Where we take online tutorials from the graduates and senior secondary students. All right, we are continuing from our previous class. This is the part 2 of the class. The part 1, I will share the link in the description, okay? So you go through it and refresh your memory so you can catch up with us. Okay, so we are going to be looking at statistical hypothesis test, and we're going to be rounding up this session. You know, I said we're going to be looking at the t-tests, the z-tests, the ANOVA, and the rest of it, okay? But we needed to understand the basics, the foundation of it, before we venture into these various tests, okay? So we're going to be looking at the one-tail versus the two-tail test, then the test statistics, then steps in hypothesis testing. Are we together? All right, if you're joining us for the first time, you're seeing us or you're joining the class for the first time, we want to specially welcome you, okay? Okay, so a test is one tail if the alternate hypothesis is what? Directional. Alternate hypothesis is what? Directional. Okay? A test is one tail if the alternate hypothesis is what? Directional. We mean, for instance, you know, when we did directional and non-directional hypothesis, when we say a hypothesis is directional, we say the hypothesis makes use of either greater than, less than. Okay? So when we have stuff like, when we have a hypothesis like XA, okay, is greater than XB, this is a directional hypothesis and is a one-tail test. So a test is one tail if the alternate hypothesis, okay, if the alternate, not null, if the alternate hypothesis is directional, either we have this or we have this, okay, or we have this, we say it's a one-tail test. But if an hypothesis is non-directional, for instance, we have XA, okay, if the alternate hypothesis is non-directional, okay, we say it's a two-tail test. We say it's a two-tail test, okay? Now, we say, let me come again. We say a hypothesis is one tail if the alternate hypothesis is directional, okay? But it's a two-tail test if the null hypothesis is non-directional. Are we together? That's the difference between a one-tail and a two-tail test. So basically, the alternate hypothesis determines whether a test or whether a hypothesis is one-tail or two-tail test. Let me come again. The alternate hypothesis determines whether a hypothesis is one-tail or two-tail test. If it is a one-tail test, the alternate hypothesis is directional, okay? But if it's a two-tail test, the alternate hypothesis is non-directional. Now, when we say non-directional, we're talking about no difference. But when we say directional, we're talking about less than, greater than, more than, or stuff like that. Do you understand it? All right. So now, the test statistics. The test statistic is like a sample statistic, okay? It's a sample statistic, okay? Used to decide whether to reject, okay? Whether to reject or accept the null hypothesis, okay? Do you get it? Now, the test statistic is a sample statistics that helps us decide, okay, whether to reject or accept the null hypothesis, okay? The null hypothesis. And the distribution is divided into two regions, okay? Hypothesis. It's divided into two regions. We have the acceptance region, and rejection region, okay? So the distribution of the sample statistic is divided into two regions. We have the acceptance region and the rejection region. Are we together? From the word acceptance region, okay, let's proceed. Let me not confuse you. So sample statistics is that the test statistic is that sample statistics that helps us decide whether to reject or accept the null hypothesis. And the distribution of the sample statistics is divided into two regions. You have the acceptance region and the rejection region. Okay, are we together? Now use the comment section, ask questions. Okay, follow me. Take it easy. Just calm down. Take a deep breath. We're taking it step by step. Wherever you don't understand or whatever you don't understand, use the comment section to ask. Are we together? So, before I explain the acceptance and rejection region further, there's what we call critical values. Critical values, okay? Critical values. Now, the critical values are sets of values, okay? Sets of values that separates, okay? That separates the acceptance and rejection regions, okay? There are sets of value that separates the acceptance and rejection region. We are getting somewhere. Just follow me. Now, I said the sample statistics helps us to decide whether to reject or accept the null hypothesis. And we have both of them here, and distribution is divided into two regions. We have this acceptance and rejection region. But we have what we call the critical values. Okay? These critical values are set of values that helps us, that separates the acceptance and the rejection region. And these values are distributed for different tables. Okay? We have, like for instance, we have, I told you the common levels of significance are, we have the 5%, okay, and the 1%, 0.0 or 0.001 or 0.05, sorry, 0.1, okay? So these are the common levels. We have for 2 tail, for 1 tail, okay? I'm talking about critical values now, okay? We have for 2 tail and we have for 1 tail, okay? Now for 5% level, for 2 tail we have plus minus 1.95, okay? Are we together? For 2 tail we have plus minus 1.65, sorry, this is 96, okay? Then for 1% level, for 2 tail, okay, we have 2.58, 2.33, okay? Yeah. So for 5% level under 2 tail, we have plus minus 1.96. For 1 tail test, we have plus minus 1.65. For 1% level, 2 tail, we have plus minus 2.58. For 1 tail, we have plus minus 2.33. These are critical values. Remember what we said about critical values, okay? They separate the acceptance region from the rejection region, okay? So we are going to see how this works, okay? Are we together? We are going to see how this critical values works on the normal distribution curve. Are we together? For 5%, for 5% 2 tail, okay, we'll have something like this, okay? We'll have something like this, 2 tail, okay? This is minus 1.96 plus 1.96. So this is the critical value that we talked about, the critical values. 1.96 minus 9.16 plus 1.96. So this is the acceptance region, okay? This is the rejection region, okay? Acceptance region and rejection region. Are we together? Then for a 1 tail test, we'll have stuff like this, okay? We'll have stuff like this. This is minus 1.65. It should be plus 1.65, okay? Yes, this is the rejection, this is the acceptance. Rejection, acceptance region, okay? This is what we're I'm just trying to demonstrate how the critical values work. Now for 2 tail test, you see, for 2 tail, these are two critical values here. Then for a one-tailed test, we'll have the minus 1.65 on this side, the plus 1.65 on this side. It's a single-tailed test because you can see how we differentiated it, because the two critical values are on one distribution because it's a two-tailed test. But here we had to separate it because it's a one-tailed test. So it depends on what values you're working with. Either you're working with the negative 1.65 or positive 1.65. That depends on the side of the distribution your values fall under. Do you understand? And the same thing goes for the two-tailed test under 1%. Okay? Let me use this part. So we have for 1% level, we have minus 2.58 plus 2.58, okay? This is the rejection, this is the acceptance, okay? Rejection region, okay? So the same thing for the one-tailed test, 2.33. Are we together? Are we together? Use the comment section if you don't understand. Subscribe if you're yet to do so, and hit the notification bell so that you get notified when we upload new classes. Are we together? All right, let's continue. So now we're going to be looking at the steps or the stages in hypothesis testing. Are we together? All right, guys. So I have gone ahead off cam to write out these steps in hypothesis testing. Okay, this is very important, very, very important. So I'll advise that you write it out somewhere, because we are going to be, when we start the test statistic properly, we are going to need these steps to help us understand it better. Do you understand? Okay, let's go over these steps and see how it works. Now, the first step is to state the two hypotheses and specify the level of significance. Okay, if we are saying, let me use the previous example we used. I said, students in JS2A are equally brilliant with students in JS2B. That's the test we want to carry out on the null hypothesis. That is the null hypothesis. Students in 2A are equally brilliant with students in 2B. Then we state the alternate hypothesis by saying students in 2A are not equal to. Now, remember, the alternate hypothesis will help us know if it's a directional or a non-directional hypothesis, or if it's a one-tailed or two-tailed test. And you'll be able to determine that from your question. I'm just giving an example. But your alternate hypothesis, you will know whether it's a directional or non-directional hypothesis, or whether it's a one-tailed or two-tailed test from the question that you'll be given, or from the assumptions you want to test. Do you understand? But for this case, let me just use a non-directional hypothesis. For it, I'm just giving an example. So, but subsequently in the subsequent class, we are going to solve a question, a comprehensive question, to help us understand directional, non-directional, one-tailed, two-tailed, all those terminologies. The question will help us understand that better. But I am just trying to explain these steps to you. So permit me to use this non-equality sign for now. Okay, so we have 2B. So now, number one step is it states the two hypotheses and specify the level of significance. So this, what I have just done here is the statement of hypothesis. Then we say at maybe 5% level, okay, or at 1% level, depending on the level you were given in the question. Are we together? Then step 2, you state the test statistics. Is it a t-test? Are we going to use a t-test? Are we to use a z-test? Is it ANOVA? Is it ANCOVA? And what kind of test? Or is it f-test? Which kind of test do you want to use? Now, the test to use is also determined from your question. Now, when samples are less than 30, when the sample size is less than 30, we are talking about small sample here. So the t distribution is supposed to be used. That is the student test, the student t distribution test. Sample statistic is going to be used. But I don't want to go into all that now, so I don't get confused. So when we start solving a question, you understand. But don't have it in front of your mind that after you state your hypothesis, Then you will now decide which of the tests to use, whether the t-test, the z-test, or the f-test, or the ANOVA test, or the chi-square, or whatever test you want to use. Okay, but that will be supplied. That will help you determine from your question. You'll be able to know the test to use from your question. So we are going to solve the question to help us with that later, not now. Then after you state your t-statistics, after you state your test statistics, the next thing to do is to state your decision rule. Now, the decision rule here says, if the calculated value is less than the tabulated value, that is to say, if z, for instance, let's say we are using the z-test. I'm using z-test now, for instance. If the calculated value, okay, z calculated is less than, okay, is less than the tabulated value, z tabulated, okay, we what? We accept the null hypothesis. So if this is less than this, we what? We accept the null hypothesis. We have stated our decision now. If z calculated, before we go ahead to solve or to impute our parameters, we will state our what? This is step 1. Step 2 is to state the statistic. This is step 3. Okay. So if z calculated is less than z tabulated, we accept the null hypothesis. Otherwise, we reject. Otherwise, we reject. So we have stated our decision now. So the next thing after that, we'll perform the calculation. Okay. We'll perform the calculation. After stating our decision, we now perform the calculation. Now, how do you perform the calculation? That test statistics you, whether the z or the t test, you now bring it. Okay? Okay, let's say, okay, now for z calculated, this z statistic, the test statistic for z now is x minus x bar, okay, all over standard deviation square root of n. So these are test statistics for z, okay? So now you perform calculation by computing what? By computing the values for this, okay? By computing the values from your question, you'll be giving that information from your question. Then when you compute the value, then they compute the value and obtain critical values from the table. Okay, when you compute the value, whatever you get here, let's say for instance, after solving, we got 0.2, for instance, 0.2 as our value for the test statistic. Okay, sorry guys, I don't know what happened to my camera, I stopped filming, okay? So sorry, I had to go back a bit. So let's say this is your test statistic and these are calculated value, okay? So all we have to do is just to compare our tabulated. Let's say our tabulated is okay, let's say 2.2, okay? Our tabulated value is 2.2. Now the tabulated value is, there's what we call the statistical table. Okay, maybe in the next class, I'm going to bring it to show you how it is. So let's say our tabulated value is 2.2. So z calculated is this, z tabulated is this. So since this one is less than the tabulated, we are going to accept what? The null hypothesis. We accept the null. Okay? So since this one is less than this, okay, we accept the null hypothesis, which says 2A, students in 2A are equally brilliant with students in 2B. So that will be our conclusion. Students in 2A are equally brilliant with students in 2B at 0.05 level of what? Significance. Okay guys, so I'm going to stop here. If you have any question, please ask me, use the comment section, okay? Alright, and in the next class, we're going to be solving a comprehensive question to help you understand it more. Alright, thank you, and see you in the next class.